Welcome everyone. We are a team of 2 people and today we are doing an experiment on the speed control of the 3-phase induction motor. Firstly, if I introduce myself, my name is Nima Zango. I study in 2nd year Instrumentation and Control Engineering at CST.
Hello everyone, welcome to our short video on speed control of 3-phase induction motor. My name is Tauzanko. I'm currently studying in 2nd year Instrumentation and Control Engineering at CST.
So if I briefly go about the theory of this practical, a 3-phase induction motor is an electromechanical energy conversion device which will convert 3-phase input electrical power into output mechanical power. So the first control method is the rotor resistance control method. Here, the rotor circuit resistance is varied by connecting a variable external resistance. The external resistance is connected in the secondary circuit in which it is shorted as the motor speeds up. So this is the formula of torque. So here torque is equal to K times S times R2 times E2 square divided by R2 square plus S2 times X2 square. So where T stands for torque developed by induction motor, K is constant, so K is equal to 3 divided by 2 pi ns. R2 is the rotor resistance per phase, E2 is the rotor EMF at standstill, S2 is slip, and X2 is the standstill rotor reactance. When the value of S is very small, so the term S2 square becomes very negligible as compared to R2 square. So torque is directly proportional to slip S and inversely proportional to rotor resistance. So therefore we can say that slip is directly proportional to rotor resistance. The second method is the variation of supply voltage method. In this method, voltage is applied to stator and is varied. Speed decreases if the supply voltage decreases below the rated value. So from the torque equation, we can say that torque is directly proportional to square of the voltage applied to the stator.
In this experiment, to control the speed of 3-phase induction motor, we are varying the supply voltage. For this experiment, the equipments that we are using are slip ring motor. In this experiment, we are going to use a star connection. For the star connection, the specifications are 400 volt, 1.15 ampere, and the rated speed of this motor is 1340 rpm. We are also using the tachometer to measure the speed of the motor. We are also using ammeter to measure the ampere. The range for this ammeter is from 0 to 5 ampere. And as you can see, we are using variable 3-phase power supply, and we are also using the voltmeter to measure the voltage. The range for this voltmeter is from 0 to 500 VAC, and we are using lots of connecting probes, so we can either use 2 or 4 mm diameter. As our connections are verified and it's made sure that it's all correct, now it's time to take readings. And first, we need to slowly start our motor by varying the power supply. Now let me first slowly increase the voltage. In this experiment, we are going to first give a rated voltage of 400 volts to the motor, and then slowly decrease and see how it affects the speed of our motor. Now as we have given a 400 volt supply to our motor. Now let's measure the speed using tachometer for 400 volt supply. Now, as you can see from this reading that we are for 400 volt supply we are getting speed of 1480 rpm. So let me first take note of that. Okay, now it's time to decrease our voltage supply and see measure the speed. Now we will vary by 50 volt interval and we will give 350 voltage. For the second reading we are giving 350 volt, so let's measure the speed. Now the speed we are getting is around 1478 rpm. 78 rpm. Now for and the voltage we are giving is 100 volt, and let's measure the speed. And the speed that we are getting is around 1340 rpm, which is the rated volt rpm speed of this motor.
Second part of our experiment is the rotor resistance control method. In this experiment, we are using the slip ring motor. So we have star connected it. So the specification for star connection is 400 volt for voltage, 1.15 ampere for current, and the rated speed is 1240 rpm. Secondly, we have used the voltmeter, and the range of the voltmeter is from 0 to 500 VAC. Thirdly, we have used a variable 3-phase power supply. Next, we are using a 3 rheostat. So each rheostat is of 50 ohm resistance. Next, we are using a tachometer to measure the speed of the slip ring motor. And lastly, we are using connecting clocks, which is of 2 mm to 4 mm diameter. Of the second experiment, that is rotor resistance control method, is firstly we have to set up the circuit connection as per the circuit diagram given. Next, we have to give the power supply from the variable 3-phase power supply to the slip ring motor. Then we have to set the speed to the rated speed, that is 1240 rpm. Next, we have to vary the 3 rheostats all together and measure the speed simultaneously. Are verified. So now let me take you through operations. The The stator terminal of the sleeping motor is star connected, and the other three terminals of the stator terminal is given from the three power supply from the variable three-phase power supply. The voltmeter is connected between the two lines to calculate the line voltage. The rotor terminal of the sleeping motor is connected to the three rheostat, and the other terminals of the three rheostats are being short circuited. I will take the first reading, which should be at the rated speed. So it is coming close to the rated speed. So you will take it as 1346 RPM. Now for the second reading, we will increase the resistance altogether. So the resistance is increased. So now we will check the speed. So the speed we have is 1305. We have tabulated all the speeds by gradually increasing the resistance. Now it is time for the last reading. So we will increase the rheostats altogether. For the last reading, we'll measure the speed. So the speed we get is 936 RPM. So we will measure the resistance of each speed. So for the first speed, which is the rated speed at around 1346 RPM, we have 88.1 ohm. Now we will increase the resistance. The value of the resistance is 89.3 ohm. We have measured the resistance of each speed. So for the last reading, we will increase the resistance. The resistance is 100.1 ohm.
From the observation table and graph, we need to observe how speed is affected by varying the supply voltage and local resistance. This is the observation table and graph of voltage control method. From the graph and the table, we see that as voltage is decreased from the rated value, the speed also decreases. From the observation table of rotor resistance control method, we can see that as we increase the rotor resistance, the speed of the induction motor decreases. Some of the precautions that we need to take while doing this experiment are: number one, we should use starter while starting the three-phase induction motor. Number two, do not exceed beyond the rated current of the motor. Number 3, before disconnecting the circuit, we should put off the supply. Number 4, we should avoid parallax error while taking the readings. Number 5, while using the tachometer, we should make sure that the tachometer is perfectly horizontal with the motor shaft. Number 6, while using the multimeter, we should make sure that the range and the unit are correct according to what we are measuring. Number 7, in rotor resistance control method, since we are using 3 rheostats altogether, we should increase the resistance of the rheostat at the same time. And number 8, we should handle all equipments with care. In this practical, we varied the speed of the 3-phase induction motor using 2 methods. First, rotor resistance control method, and second, the variation of supply voltage method. From the first rotor resistance control method, we have observed that with increase in the resistance of the rotor, the speed decreases. So therefore, we can say that the speed is inversely proportional to the rotor resistance. From the second method, the variation of voltage supply method, we have observed that as we decrease the voltage from the rated voltage of the motor, we have observed that the speed also decreases. So therefore, from this we can say that the speed is directly proportional to the square of the applied supply voltage.